This video is for the Optical Pulse Monitor Lab, Lab 6 or Chapter 25 of Applied Analog Electronics. Now, the optical pulse monitor is a simplified version of a pulse oximeter. The idea of the pulse oximeter is that it shines light through a finger using two different wavelengths. And the light shining through the finger gives you both a pulse rate from the fluctuations in opacity of your finger, and by doing this at two different wavelengths, it can also estimate the oxygenation of the blood. Here it's estimating 98% oxygenation with a pulse rate of about 51 beats per minute, or 49 now. Okay, what you're going to be doing with your optical pulse monitor is just using one optical channel. We'll just have a phototransistor. And what we'll be doing is measuring how much light that phototransistor sees, and that fluctuations in light will be due to fluctuations in the opacity of the finger that are due to the pulse. So we don't want any fluctuations that are due to anything other than the pulse. So we're going to put this black Lego brick with a hole drilled through it as sort of a shroud to keep other light around there. Because there's an opening on the bottom of the brick, we'll put another black Lego brick there to block that also. So now the only light coming in here is through this hole on top. There's black electrical tape on the back side to keep any light from coming in that way. Now it's kind of hard with just these two bricks to rest your finger on it. So you can use a couple more Lego bricks to make a stand for it. Just clip it on there. I'm going to use a slightly bigger stand because I got lots of Lego. And the idea is just to hold it together so that the light only comes in through the top. There's no strain on the wires. I'm not pushing on the wires at all because they've got a bit of a gap there. All right, and then you just rest your finger on here. The light shining through it will fluctuate in a way that should be recordable after amplification. All right, so let's switch over to looking at Teradek. I'm going to be sampling at 30 times a second. That's so that if there's any 60 hertz noise here, and there usually is 60 hertz noise, it'll get aliased out. It gets aliased to DC. All right, I will start recording and then put my finger on it. When I put my finger on it, you can see there was a big change, and then it took a while for the high-pass filter that removes the DC bias to settle down again. And you can see I'm getting quite a large signal here. Now it takes some practice to get a large signal like this because what I'm doing is I'm pressing on my finger lightly so that it just begins to throb. That is to say, I'm getting pressure between my systolic and diastolic pressure. And that means that the blood flow is sort of maximally changing opacity because the high part of the high pressure part of the flow, I get quite a bit of blood going through, and the low pressure I get almost none going through. Now, if I press very lightly, so that I'm not getting that throbbing, I can still see a pulse, but the signal is much smaller. If I press very hard, so I squeeze all the blood out of my finger, I don't really see a pulse anymore. Those fluctuations I'm seeing, maybe just hand tremor, changes in how much pressure I've got on my finger, and may or may not be related to my pulse. Looks like there's a little bit there, but I mean, I can wiggle my finger and get much larger fluctuations than what I'm seeing from the pulse. But if I relax it and get just a light pressure there, then I can get a very good signal. So it takes a little bit of practice. If you remember the pulse oximeter, I didn't have this problem, and that's because the pulse oximeter has a little bit of spring to provide approximately the right amount of squeeze to your finger without requiring skill on the part of the person whose pulse is being taken. The only thing that's left for us to do at this point really is to take one of these recordings that we're going to make with Teradek and determine what the pulse rate is from that. And I'll do that in a separate video.